Great. Such a nice talk by Mike and Eric, and looks like we are doing something similar. So I'm pretty excited what they have done. I would like to use Rise.tools in my projects. But yeah, I'm Sanket Sahu. As Sahil mentioned, I run this company called Geeky Ants, and you might know us from this open source library called Native Base, which is a UI component library for React and React Native. And now we have the new version of Native Base that is called GlueStack UI. We call it the better UI library because, you know. But yeah, this is the caravan that Sahil was talking about. I sometimes eat, sleep, code, travel, and do everything in the caravan. I have taken it twice to Goa and once to Chikmagalur. But yeah, this is the one that I built myself. And yeah, today I'm going to talk about building universal apps, just like CLIs. So it's slightly different from the last talk. This is more towards how you can build full stack and universal apps. Universal as in it works for Android, iOS, and web, just like the good old days of CLIs. Okay, before I get into my talk, I have this question. What was your first programming language? C, C++, Java, seriously, the first programming language. I feel sorry. Assembly, Santosh, yes. Anyway, before I answer what was my first programming language, this is the first computer from my house that my dad got in late 1980s. This is a Z80 processor. I mean, this is not the actual picture because I found it from the internet. This is a Z80 processor computer, similar to 8088 that you might have read in your books. It had the same API, and the computer that we had, it was just keyboard, and it had CPU inside the keyboard, and you had to actually connect it to a TV to see the output. And even it didn't have any memory, like hard disk and all those things. We had to save our programs in tape recorder. Yes, yeah. Late 1980s. So when I was growing up, I didn't see this. I'm not that old. But yeah, when I was growing up, my first programming language was QBasic. Any QBasic fans here? A few hands I can see. I'm growing old. But yeah, this is how it used to look like. It was blue, just like Radisson. Sorry, bad joke. But, but yeah, this is similar to C++ Turbo C editor. You might relate to it, but this is what we had. And the code looked like this. It was that simple. There was no server. There was no client. It was just like 10 lines of code to do a bunch of things. Okay, let's have a close look at it. So CLS was to clear the screen. If you have used MS-DOS, you might be familiar with CLS. And after that, to write my first program, what I did, input, what is your name, and then give a variable name. It had dollar at the end, quite the opposite of PHP. And then on the next line, I can do print hello name dollar, and it would just run fine. I mean, this is the whole code, 3 lines of code, and it's pretty straightforward for anyone like getting into coding. It was not that complicated. And this was my introduction, and that's what like I got excited about computers. I can build CLIs. Pretty simple. How about Node.js? So I try to build the same in Node.js, and again, 3 lines of code here: await, ask question, what is your name, and then console log, hello, the name, and process.exit. That's in a main function, and I execute that. But what is that ask question over there? Okay, so I hid a part of the code just to make it simpler. So since this is an async language, we have to return a promise and look for that event when the user presses enter and get that whole output from the user. Slightly complicated than what was there in QBasic. I try to run it, and this is how it looks like. So you can run it on CLI, say node space hello name, and it asks for your name, and yeah, you get the whole output on CLIs. Great, but what about HTML and JavaScript? So for HTML, we have to first write the HTML markup, and then in the body, we define the form. Okay, we have input, we have a button, we have an empty placeholder div where we are going to give the output, and then we wire up the onClick function, greet user here, and then write those in the script tag. So in the script, we'll write greet user, and then it reads the element's value, the input value, and then concatenates that in a string, and then writes that in the inner HTML. Slightly more complicated, because here we are doing like defining the template first, and then wiring this whole logic into a different language altogether. So mix of two languages here. But yeah, it works. So if I go and run this code, this is the output. So you have the markup, and you write something, and then click on submit. It updates the DOM, and you get the output. But you may ask, isn't that just the front end? So let's bring in a server. So we create the Node.js server using Express. We create some routes, say /route, that will give the first form. Then we'll have another route, which will accept the input from the first route into a greet post method, and then start the server. And how does the input look like? So how does the response from the first route look like? So it's the same markup, very similar to what we had in the previous example. But here we have a form instead of onClick, and this form submits to greet, and then it goes to the post route, greet post route, and then that is handled, and we get another response from the server, which is a new HTML page. Pretty straightforward for an HTML, CSS developer with some backend code. But here we have the whole server. We can do a bunch of more things. So now we are running this in localhost 3000, and then you write something, and it navigates the user to a new page. Here we can like interact with the database and store the information and do something more secure, because it's not just the front-end code anymore. But you might say, okay, this is not interactive. We are in a React conference, and you're talking some 90s code. So let's bring in some React and some APIs on top of that, and probably also do SSR. And ultimately, what we reach to is obviously Next.js. That is all Next.js is all about. So I got really lazy at this point and asked ChatGPT, okay, give me the same code in Next.js. And ChatGPT gave me this whole bunch of folder structure that I need to go through, and then write an API route. And that API route is greet.js inside my API folder, which returns the response. And then we have the actual index.js inside the pages folder. And we have the markup, which submits and runs and calls the API, and then responds. But the point that I'm trying to make is you have to do a lot of things to get to that simple code that was just 3 lines of code back then. What if we could build apps like CLIs? Can we get to the same philosophy or same way of writing, same way of mental modeling our apps with those 3 lines? So obviously, I built something. And this is how it looks like. So it's the setup that I have. You don't need to worry about the setup. But it starts from the invoke function. And with the 3 lines of code, we can do something like ui.print. And this is Node.js in the backend. And you can do, say, write the next line, say, let name is equal to await ui.scan, and enter your name. And then, yes. And then you can have ui.print, hello, that name. Again, 3 lines of code, back to the original idea of QBasic C, and this works. This is a whole full stack web app which has backend, frontend, fully interactive in those 3 lines of code. Nice? Yeah? And that's not it. Since this is driven by the server, you get the whole iOS and Android app for free. And this just works. Okay. I know, I'm going to get questions, which screen recorder did you use? But yeah, this works. So that was at React Berlin, the demo. But yeah, and you also get the Android app with just those 3 lines of code. So server-driven UI, very similar, but somewhat different as well. I'll get to that point. Great. The mental model here is it's a server process, and all the clients that connect with the server, they are treated as an I/O. So we have the server, we have io.print from the server that takes the JSON output and shows to the client, and the client uses a renderer component with the same data that is received from the server, and it renders it on the screen. And any interaction that happens on the client, it again goes back to the server. Very similar to the last talk, up and until here, with a reference ID. And the renderer data is again very similar to the JSON that Mike and Eric showed in the last talk. This is the UI, and type is print, and children is what is your name. The renderer component looks like this. If the type is print, throw in a print component. If the type is scan, throw in a scan component. We can define new ones as we go as well. That's on the roadmap, but yeah, this is just an experiment, and yeah, how we can build one too. So if we connect a client on the server, we have to start a client process on the backend, and if we start the second or connect the second client, that's another process that runs. So this is something different than server-driven UI. We are invoking a whole new process whenever a client connects, and we are maintaining the whole state of every client on the server, which is interruptible. And this is slightly different. So when the client 1 connects, it can be on a different state altogether. When the client 2 connects, the whole state can be, say, it can be on some different route. And all those things are maintained on the backend. So you get more control here. You can interrupt anything what happens on the client without sending another connect request or anything like that. So it's interruptible. You can wait for the user's input, which is slightly different. And here the clients are, it can be Chrome, it can be iOS, Android. Ultimately, it's React and React Native. The stack that I used here with React is definitely React Native, and I used Expo to build all those web and mobile apps. And on top of that, I used the UI component library, GlueStack UI, which we built. And on the server, it's Node.js. The socket connection is Socket.io, and the actual business logic, the entire business logic of the app resides on the server, and there's nothing on the front end. Everything is just empty. So yeah, what about Gen AI? I mean, we have all these AI words, right? And the buzz of AI, we have to talk about it. So I went ahead and shared this bit of code, the 4 lines of code with ChatGPT, and I was like, I'm building a new framework, and this is how it looks like. Can you help me write an app using this framework that asks to add 2 numbers? And this is the whole input that I gave to ChatGPT. And then it gave me some code. I did not read that code. I just clicked copy and then pasted it in the same invoke method that had my setup. And I tried to run it without any changes, 0 change. And we have the fully running code with a new framework that ChatGPT understands and generates, and it adds 2 numbers. As simple as that. Yeah. And this is for all the platforms, not just web. I got very excited, and then I was like, started throwing random requests to ChatGPT. Okay, let's do this. Let's do a multiplication table. And I did that, and then it gave me a whole multiplication table. Pretty straightforward, right? When ChatGPT understands the basics of anything, you can throw in these requests. But these are like toy projects. You would say, okay, who does multiplication tables on a production level app, right? So I got serious and asked ChatGPT, probably give me an authentication flow, and asks for username and password and authenticates them using DB. Assume that we are using Prisma. And ChatGPT gave me the correct code. I mean, I was really surprised that with just 4 lines of input, I could train ChatGPT with a whole new framework that actually asks for username, password, and then actually validates those things using find unique of Prisma and returns if that authentication happened or not. So we can build like fully blown flows in very less lines of code. Like you can just, it's like 10 lines of code, and that's a full authentication thing, right? But yeah, this works. The question, is it server-driven UI or it is not? A part of it is yes, but it is different. It is different in the sense that it is interruptible from the server. So the server throws in some server-driven UI and then also waits for some input, and you still maintain that flow at the backend. In the backend, you can actually wait for the inputs from the users and then act on it. So it's interruptible server-driven UI, this experiment. And again, it's slightly different. RSCs can be a subset of it, but it's interruptible RSCs is what I believe. Is it SEO friendly? Can we build like full websites? It is not, at least today, but it is possible. We can throw in the same thing to an edge function, and edge function can actually render the whole page on the edge client, and it can be SEO friendly too at some point. Is it scalable? I think yes, it's totally scalable. But yeah, it's just a side project right now. It's an experiment. It can be used for internal apps, dashboards, general purpose websites, or apps, maybe. There are inspirations. There's this project called Streamlit. That's a Python-based backend-driven thing. And then internal is another inspiration that I saw. And then the future. So the future, I think, I would go back to the last talk. I think it's so surprising that me and Mike, we started our companies during the same time, and we were doing similar things in React Native. And Eric was also doing something similar. And today we are also doing something similar. But the journey is like we are intersecting. That's the future. I think the server-driven UI and interruptible server-driven, I think that's the future, and we are very excited. We are here for it. And probably we could build the whole dashboard like this using backend or server-driven only. So this is just an experiment right now. You can probably scan this QR code. It's available under Geeky Ant's handle. And yeah, would love to talk more about it in the break, and would love to collaborate. So yeah, that's me, Sanket. Thank you so much. Yeah.
Thank you, Sanket. Can we have a huge round of applause for Sanket?